Welcome to all of you. Myself, Professor Manoj Manik Charate, working as a lecturer in Mechanical Engineering Department in Brahmadev Dadamane Polytechnic, Solapur. Today, I will deliver lecture on fundamentals of thermodynamics from thermal engineering subject. In that, today I will cover these points. First, properties of system. In that properties of system, intensive property and extensive properties. Second, processes. In that processes, there are two types of processes: flow process and non-flow process. Next, third, concept of specific volume and density. Fourth, concept of pressure and temperature. First of all, we will see properties of system. What mean by properties of system means any measurable characteristics of a system is known as a properties of a system. In that there are two types: intensive property and extensive property. Intensive property means those property which are independent on the mass of the system is known as a intensive property. Its example: pressure, temperature, etc. Intensive property in that this property does not depend on the mass of the system, so it is known as a intensive property. Extensive property which are dependent on the mass of the system, so it is known as a extensive property. Its example: mass, volume, energy, enthalpy, etc. Let us consider one system having its mass m, volume v, temperature T and pressure P. We can this system divide into two parts. First one left side and other one in right side. When we divide this system into two parts, then mass will be become on left side m upon 2, volume v upon 2, and on right side same m upon 2 and volume v upon 2. But temperature in left side portion T, right side portion T, left side pressure P, on right side pressure P, means temperature and pressure on both this system remains constant, but mass and volume will be divided. Means this mass and volume are the properties which are dependent on the mass of the system, but temperature and pressure does not depend on the mass of the system, so it is known as an intensive property, and mass and volume are known as a extensive properties. Here we consider these two systems: m upon 2 plus m upon 2 is equal to m, means mass and volume are the extensive property which are in additive in nature, but temperature and pressure are not in additive in nature. And here temperature and pressure. Temperature we can measure by using thermometer. Pressure we can measure by using pressure gauge. Means intensive property can be measured by using instrument, but extensive property can be calculated by using formula, like volume is equal to area into height. Means extensive property we can measure by using formula, and intensive property we can measure by using instruments. Next, processes. In that processes, two types of processes: flow process and non-flow process. What mean by flow process? The process which are carried out in open system which permit cross the mass throughout its boundary is known as a flow process. means in that flow process is a in which occur on a open system. In that mass can be transferred, means mass can cross its boundary, that is known as a flow process. Its example is a fluid flow in a pipeline. In that pipeline, mass will be enter in the system and mass will be out in that from the system, means this fluid can cross the boundaries, so it is known as a flow process. Example of flow process are turbine, boiler, compressor, pump, etc. And in that flow process, the flow may be steady flow or unsteady flow. Next, non-flow process. The non-flow process, the process which occurring in a closed system which do not permit cross the mass throughout its boundaries, is known as a non-flow process. Means non-flow process occurring in a closed system. Its examples closed piston cylinder arrangement, in that some gases are filled out in that cylinder. In that system, the mass does not cross these boundaries from system to surrounding or from surrounding to system does not cross, so it is known as a closed system. And thus those which system does not permit to transfer the mass throughout its boundary, that system is known as a non-flow process. It's in that process it may be isochloric process, isobaric process, or isothermal process. In non-flow process, these processes are occur isochloric process, isobaric process, or isothermal process. In isochloric process, volume remains constant. In isobaric process, pressure remains constant, and in isothermal process, temperature remains constant. Next, specific volume and density. Specific volume is the ratio of volume per unit mass, is known as a specific volume, and specific volume can be indicated by using symbol V, and its unit is meter cube per kg. Its formula is volume per unit mass. specific volume is the ratio of volume per unit mass. Its unit is a meter cube kg. Next point is the density. Density is the ratio of mass per unit volume, and density is indicated by symbol rho, and its unit is kg per meter cube. Another way we can explain density. Density is a reciprocal of specific volume. Suppose example, we consider a two container. Consider two containers having identical volume. Suppose 10 meter cube. In that containers, in first container, some balls we are added, and in another container we are added some balls, but in another container the quantity of balls added are large. So when we calculated mass of this ball, suppose a container, in that ball mass is a 5 kg, and in that second container ball mass is a 15 kg. When we calculated density of first container is a mass is a density formula is a mass upon volume. So rho 1 is equal to mass 5 kg, volume 10. So its density is a 0.5 kg per meter cube, and in second container rho 2 is equal to 15 upon 10. So its density will become 1.5 kg per meter cube. Means in second container large quantity of balls are present, so its density is greater than first container. Next bit is a pressure and temperature. Pressure is a force per unit area. Pressure is a ratio of force per unit area. The pressure will be indicated by using P. Its unit is Newton per meter square or Pascal or bar. 1 atmospheric pressure is equal to 1.01325 bar. Pressure can be measured by using pressure gauge. Next term is a temperature. Temperature is a degree or intensity of heat present in a subject or object is known as a temperature, and temperature can be indicated by symbol T, and it can be measured in units degree Celsius, Kelvin or Fahrenheit. For measuring the temperature, thermometer is used or thermocouple is also used. Okay, thank you.